CIET NCERT presents Audiobook of Mathematics for Class 6. Chapter 1,
Part 4.
Page 22, 1.3.7. To estimate products. How do we estimate a product? What is the estimate for 19 multiplied by 78? It is obvious that the product is less than 2000. Why? If we approximate 19 to the nearest tens, we get 20, and then approximate 78 to nearest tens, we get 80, and 20 multiplied by 80 is equal to 1600. Look at 63 multiplied by 182. If we approximate both to the nearest hundreds, we get 100 into 200, which is equal to 20,000. This is much larger than the actual product. So, what do? To get a more reasonable estimate, we try rounding off 63 to the nearest 10, that is 60, and also 182 to the nearest 10, that is 180. We get 60 multiplied by 180, or 10,800. This is a good estimate, but is not quick enough. If we now try approximating 63 to 60 and 182 to the nearest hundred, that is 200, we get 60 into 200, and this number, 12,000, is a quick as well as good estimate of the product. The general rule that we can make is, therefore, round off each factor to its greatest place, then multiply the rounded off factors. Thus, in the above example, we rounded off 63 to tens and 182 to hundreds. Now, estimate 81 multiplied by 479 using this rule. 479 is rounded off to 500, rounding off to hundreds, and 81 is rounded off to 80, rounding off to tens. The estimated product is equal to 500 multiplied by 80, which is equal to 40,000. Try these. Estimate the following products. A. 87 multiplied by 313. B. 9 multiplied by 795. C. 898 multiplied by 785. D. 958 multiplied by 387. Make 5 more such problems and solve them. An important use of estimates for you will be to check your answers. Suppose you have done the multiplication 37 multiplied by 1889, but are not sure about your answer. A quick and reasonable estimate of the product will be 40 multiplied by 2000, that is 80,000. If your answer is close to 80,000, it is probably right. On the other hand, if it is close to 8,000 or 8 lakh, something is surely wrong in your multiplication. Same general rule may be followed by addition and subtraction of 2 or more numbers. Page 23. Exercise 1.3. 1. Estimate each of the following using general rule. A. 730 plus 998. B. 796 minus 314. C. 12,904 plus 2,888. D. 28,292 minus 21,496. Make 10 more such examples of addition, subtraction, and estimation of their outcome. 2. Give a rough estimate, that is, by rounding off to nearest hundreds, and also a closer estimate by rounding off to nearest tens. A. 439 plus 334 plus 4,317. B. 1,08,734 minus 47,599. C. 8,325 minus 491. D. 4,89,348 minus 48,365. Make 4 more such examples. 3. Estimate the following products using general rule. A. 578 multiplied by 161. B. 5,281 multiplied by 3,491. C. 1,291 multiplied by 592. D. 9,250 multiplied by 29. Make 4 more such examples. 1.4. Using brackets. Meera bought 6 notebooks from the market and the cost was 10 rupees per notebook. Her sister Seema also bought 7 notebooks of the same type. Find the total money they paid. Seema calculated the amount like this: 6 multiplied by 10 plus 7 multiplied by 10 equal to 60 plus 70, which is equal to 130. Answer: 130 rupees. Meera calculated the amount like this: 6 plus 7 is equal to 13 and 13 multiplied by 10 is equal to 130. Answer: 130 rupees. You can see that Seema's and Meera's ways to get the answer are a bit different, but both give the correct result. Why? Seema says what Meera has done is 7 plus 6 into 10. Appu points out that 7 plus 6 into 10 is equal to 7 plus 60, which is equal to 67. Thus, this is not what Meera had done. All the 3 students are confused. To avoid confusion in such cases, we may use brackets. We can pack the numbers 6 and 7 together using a bracket, indicating that the pack is to be treated as a single number. Thus, the answer is found by 6 plus 7 within brackets multiplied by 10, which is equal to 13 multiplied by 10. This is what Meera did. She first added 6 and 7 and then multiplied the sum by 10. This clearly tells us, first, turn everything inside the brackets into a single number and then do the operation outside, which in this case is to multiply by 10. Page 24. Try these. 1. Write the expressions for each of the following using brackets. A. 4 multiplied by the sum of 9 and 2. B. Divide the difference of 18 and 6 by 4. C. 45 divided by 3 times the sum of 3 and 2. 2. Write 3 different situations for 5 plus 8 within brackets multiplied by 6. One such situation is Sohani and Rita work for 6 days. Sohani works 5 hours a day and Rita 8 hours a day. How many hours do both of them work in a week? 3. Write 5 situations for the following where brackets would be necessary. A. 7 multiplied by, within brackets, 8 minus 3. B. Within brackets, 7 plus 2 multiplied by, within brackets, 10 minus 3. 1.4.1 Expanding brackets. Now, observe how use of brackets allows us to follow our procedure systematically. Do you think that it will be easy to keep a track of what steps we have to follow without using brackets? 1. 7 multiplied by 109 is equal to 7 multiplied by, within brackets, 100 plus 9, which is equal to 7 multiplied by 100 plus 7 multiplied by 9, which is equal to 700 plus 63, which is equal to 763. 2. 102 multiplied by 103. This is equal to, within brackets, 100 plus 2 multiplied by, within brackets, 100 plus 3, which is equal to, within brackets, 100 plus 2 multiplied by 100 plus, within brackets, 100 plus 2 multiplied by 3. This is equal to 100 multiplied by 100 plus 2 multiplied by 100 plus 100 multiplied by 3 plus 2 multiplied by 3, which is equal to 10,000 plus 200 plus 300 plus 6, which is equal to 10,000 plus 500 plus 6, which is equal to 10,506. 3. 17 multiplied by 109. This is equal to, within brackets, 10 plus 7 multiplied by 109, which is equal to 10 multiplied by 109 plus 7 multiplied by 109, equal to 10 multiplied by, within brackets, 100 plus 9 plus 7 multiplied by, within brackets, 100 plus 9. This is equal to 10 multiplied by 100 plus 10 multiplied by 9 plus 7 multiplied by 100 plus 7 multiplied by 9, which is equal to 1000 plus 90 plus 700 plus 63, which is equal to 1790 plus 63, which is equal to 1853. 1.5 Roman numerals. We have been using the Hindu-Arabic numeral system so far. This is not the only system available. One of the early systems of writing numerals is the system of Roman numerals. This system is still used in many places. For example, we can see the use of Roman numerals in clocks. It is also used for classes in the school timetable, etc. Find 3 other examples where Roman numerals are used. Next to this, we can see a picture of clock using Roman numerals. Page 25. The Roman numerals. I, IV, V, VI, VII, VIII, 1x, x, denote 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 respectively. This is followed by xi for 11, xii for 12, till xx for 20. Some more Roman numerals are I, 1, V, 5, X, 10, L, 50, C, 100, D, 500, M, 1000. The rules for the system are: A. If a symbol is repeated, its value is added as many times as it occurs. That is, II is equal to XX is 20 and XXX is 30. B. A symbol is not repeated more than 3 times, but the symbols V, L, and D are never repeated. C. If a symbol of smaller value is written to the right of a symbol of greater value, its value gets added to the value of greater symbol. Vi is equal to 5 plus 1 is equal to 6. Xii is equal to 10 plus 2 is equal to 12. And LXV is equal to 50 plus 10 plus 5 is equal to 65. D. If a symbol of smaller value is written to the left of a symbol of greater value, its value is subtracted from the value of the greater symbol. IV is equal to 5 minus 1 is equal to 4. IX is equal to 10 minus 1 is equal to 9. XL is equal to 50 minus 10 is equal to 40. XC is equal to 100 minus 10 is equal to 90. E. The symbols V, L and D are never written to the left of a symbol of greater value. That is, V, L and D are never subtracted. The symbol I can be subtracted from V and X only. The symbol X can be subtracted from L, M and C only. Following these rules, we get 1 is equal to I, 2 is equal to II, 3 is equal to III, 4 is equal to 1V, 5 is equal to V, 6 is equal to VI, 7 is equal to VII, 8 is equal to VIII, 9 is equal to IX, 10 is equal to X, 20 is equal to XX, 30 is equal to XXX, 40 is equal to XL, 50 is equal to L, 60 is equal to LX, 70 is equal to LXX, 80 is equal to LXXX, 90 is equal to XC, 100 is equal to C. A. Write in Roman numerals the missing numbers in the table. B. XXXX, VX, IC, XVV are not written. Can you tell why? Try these. Write in Roman numerals 1. 73, 2. 92. Page 26. Example 7. Write in Roman numerals A. 69, B. 98. Solution. A. 69 is equal to 60 plus 9, which is equal to, in brackets, 50 plus 10 plus 9, which is equal to LX plus IX, which is equal to LXIX. B. 98 is equal to 90 plus 8, which is equal to, in brackets, 100 minus 10 plus 8, which is equal to XC plus VIII, which is equal to XCVIII. What have we discussed? 1. Given two numbers, one with more digits is the greater number. If the number of digits in two given numbers is the same, that number is larger which has a greater leftmost digit. If this digit also happens to be the same, we look at the next digit and so on. 2. In forming numbers from given digits, we should be careful to see if the conditions under which the numbers are to be formed are satisfied. Thus, to form the greatest 4-digit number from 7, 8, 3, 5 without repeating a single digit, we need to use all 4 digits. The greatest number can have only 8 as the leftmost digit. 3. The smallest 4-digit number is 1000. It follows the largest 3-digit number, 999. Similarly, the smallest 5-digit number is 10,000. It is 10,000 and follows the largest 4-digit number, 9,999. Further, the smallest 6-digit number is 1 lakh. It is 1 lakh and follows the largest 5-digit number, 99,999. This carries on for higher digit numbers in a similar manner. 4. Use of commas helps in reading and writing large numbers. In the Indian system of numeration, we have commas after 3 digits starting from the right and thereafter every 2 digits. The commas after 3, 5 and 7 digits separate thousand, lakh and crore respectively. In the international system of numeration, commas are placed after every 3 digits starting from the right. The commas after 3 and 6 digits separate thousand and million respectively. 5. Large numbers are needed in many places in daily life. For example, for giving number of students in a school, number of people in a village or town, money paid or received in large transactions, that is, paying and selling, in measuring large distances, say between various cities in a country or in the world, and so on. 6. Remember, kilo shows 1000 times larger, centi shows 100 times smaller, and milli shows 1000 times smaller. Thus, 1 kilometer is equal to 1000 meters, 1 meter is equal to 100 centimeters or 1000 millimeters, etc. 7. There are a number of situations in which we do not need the exact quantity but need only a reasonable guess or an estimate. For example, while stating how many spectators watched a particular international hockey match, we state the approximate number, say 51,000. We do not need to state the exact number. Page 27. 8. Estimation involves approximating a quantity to an accuracy required. Thus, 4,117 may be approximated to 4,100 or to 4,000. That is, to the nearest 100 or to the nearest 1,000, depending on our need. 9. In number of situations, we have to estimate the outcome of number operations. This is done by rounding off the numbers involved and getting a quick, rough answer. 10. Estimating the outcome of number operations is useful in checking answers. 11. Use of brackets allows us to avoid confusion in the problems where we need to carry out more than one number operation. 12. We use the Hindu-Arabic system of numerals. Another system of writing numerals is the Roman system. You were just listening to the audiobook Mathematics for Class 6. Narrator Gaurav Marva. Assistance in production Soumya Malik. Producer Vimlesh Chaudhary. Presented by CIET NCERT, New Delhi, India.